Welcome to Brain Vision.
Now in this question we have a block being connected by two springs. So on the left we have the first spring with spring constant K1, and on the right is a spring with spring constant K2. Now what we want to find is what is the maximum speed when after we actually compress the block or move the block towards the right by 0.15 meters or 15 centimeters, and it is released. Right? We want to find the maximum velocity. So maximum velocity is when the kinetic energy of the block is a maximum, and this is when all the elastic potential energy that was stored right just before it was released is actually converted into kinetic energy. So Ke max must be equals to the total elastic potential energy at the start. Total elastic potential energy we can find by using half kx square. Now x, we know that for the spring on the right it is being compressed, and on the left it is being stretched by the same amount, so they will have the same x, right, in terms of compression and extension. So that's 0.15 squared. K, however, is different, right? So for K1 we are given to be 25 newtons per centimeters. Converting that into SI units is 2,500 newtons per meter. Right? Same for K2. K2 will be 2,000 newtons per meter. So evaluating this, we should get a value of about 50.6 joules. Right, you can equate this to half mv square. Right, we want to find what is our velocity v. So we just divide the mass, which is 3, multiplied by 2, and then we take the square roots of everything. Should get about 5.8 or about 6. 5.8 meters per second. So this is the maximum speed. Now to find what is the maximum compression of spring 1, well, we're going to estimate the compression to be an unknown value of x. Now we know that the total energy must be equal to the total initial elastic potential energy, which is equals to 50.6 over here. And so when it is actually extended to the left, we will expect the total compression to also give us a total elastic potential energy of 50.6. And this will mean that half K1 times x square plus half K2 times x square must be equals to 50.6 joules. Now we know that the extension for the spring number 2 will be the same amount in terms of x because they are connected together. And in fact, with this particular expression, we see that it is actually very familiar to our initial expression right over here for our initial total elastic potential energy. And so we can actually infer that our x must be equals to 0.15 meters. It's the same amount of compression at the start, same amount of extension at the start. Sorry.